Yeah, good morning to all and welcome you all for the 14th lecture on basic circuit theory. So last class what we discussed, anyone? Last class what we discussed and where we are? Guys, are you with me? Guys?
There are nodal analysis.
Yeah. Nodal analysis. Okay. So actually the full name is nodal voltage analysis. So what you are doing? First you are applying KCL, then you are writing the formula for I with the help of Ohm's law. So KCL plus Ohm's law will give you nodal voltage analysis. And I have given 8 cases. Do you want to recall those 8 cases or straight away shall we solve some more problem? Please respond. Do you want to recall those 8 cases?
We can solve the problems.
Okay. Then take this case, okay, just for your understanding. Suppose this time take case number 9. Now, what is the formula for I? Anyone?
V1 minus V2 minus V3 by R.
I is flowing from this time right to left. See the direction of I. V2
minus V1
minus V1 minus
V3
V3 divided by R1 plus R2, isn't it? So take case number 9 just for your reference. And suppose take one more case number 10.
Sir, அது plus V3 தானே சார் வரும்.
Yeah, plus V3, thank you. Take this case. This we never get it, but anyhow, just for your reference. V1, V2, V3, V4, R1, R2. Yeah, now what is the formula for I? Anyone? And I current direction, this time left to right. Yeah, anyone? What's the formula for I? I equal to V by R, where R is R1, R2 are contained in series, so it becomes R1 plus R2. So as usual notation, starting voltage minus ending voltage. For intermediate, you want to put your bracket and you want to consider the starting polarity. Okay. Suppose now what is the formula for I? Anyone? Is it possible to calculate I for this case number 11?
Sir, infinity sir.
I there is no so R equal to 0. So it is not possible to find I. So how will you approach this kind of problem? What is the name for this kind of problems? Like nodal. After that we are having super nodal. Okay, so you know when you will apply super mesh, if a current source is common, okay, super mesh na என்னப்பா? Current source is common between two loops, then we will apply super mesh. Similarly, when you will apply super nodal, voltage source is common. If a voltage source is common between two nodes, okay, like here, voltage source V3 is common between node 1 and 2. This is my node 1 and this is my node 2. Okay, so this time we want to apply super nodal. So this time what is the equation? How will you develop the equation? Simply apply KVL. Okay, apply KVL. So this is V1. So இது எப்படி இருக்கும்? Actually plus and minus connected here. This is V2. So plus and minus connected here. So both are minus. So common ground, right? So this is my V1 plus minus and this is my V2 plus minus. Now can you apply KVL? So it is minus 2 plus. So minus V1. It is plus 2 minus. So plus V3. It is plus 2 minus. So plus V2 equals 0. Therefore V1, yeah, minus V2 equals V3. So this is the way, okay, to develop super nodal. Okay, like we developed the equation at super mesh, right? So similarly, what do you want to do? You want to apply KVL. So whenever you are finding a common voltage source between two nodes. Are you clear? So now take this and then we will solve some more problem based on nodal. Then we will move to super nodal. So this is my today's plan. Two problem I want to solve. Okay, once again I want to solve on same nodal. Then two more problem on super nodal. Then we will move to. So till now actually we are playing with only independent sources. Then later on we will play the same concept. Okay, on dependent sources. So that's the idea. So now take this case number 9, 10, 11. Okay. Once if it is taken, please let me know. Then I will move to the next. I will give the problem. Take example 1 for today's class. My another favorite problem. Question is compute I1. So shall we proceed? Actually, compute I1. You know how to calculate I1 by using mesh analysis. Okay, you are having three loops, so you will assume I1, I2, and I3. But here it is given I1, so don't worry. Later you can replace that. So go with our own style. Then you can find I1. But the thing is, compute I1 using nodal analysis. Suppose if the question they are asking like this, if anything is not mentioned, then you can either go with mesh or nodal. If it is mentioned, then you can go with that method. So here it is clearly mentioned, compute I1 using nodal analysis. So this time what you want to do? What's the very first step in nodal? You want to find the number of essential nodes. So here this is node 1. Node is represented by a number. அதுக்கப்புறம் round பண்ணீங்கன்னா இது node. Suppose number மட்டும் போட்டீங்கன்னா அது branch. Suppose ஒரு register இருக்கு, this is a branch. 1, 2. இந்த மாதிரி நம்பர் மட்டும் போட்டிருந்தா அது branch. இந்த மாதிரி நம்பரை போட்டு ரவுண்ட் பண்ணிருந்தா அது node. Okay, just for your information. எக்ஸாம்பிள் இப்பெல்லாம் இருக்காது கொஸ்டின்ல. This is just a circuit notation. So this is node number 2. So this is node number 3. But I want to take this one as reference node. So here the voltage is 0. Okay. If you know nodal, please try to solve by yourself. So here the voltage is V1. Here the voltage is V2. Okay. So now can we apply KVL at what is this? Loop 1. Sorry. Apply KCL at node 1. Apply KCL at node 1. So at node 1, how many branches? At node 1, how many branches? Anyone? So 3 branches. Assume all are leaving current. Okay. But here, see, this one is entering. So as per the given notation, okay, I want to take this one as entering current. Okay. So this time I am having some entering current 2 equals leaving current 2 more. What about this current? That you know V1 minus 0 divided by 7 plus 3. And what about this current? This you know V1 minus V2 divided by 15. சண்டே கிளாஸ் வந்து கூட அவ்வளோ இன்ட்ராக்டிவாக இருந்துச்சு. இது மண்டே வாரத்தில் ஃபர்ஸ்ட் நாள் ஃபர்ஸ்ட் ஹவர். ஓகே ப்ளீஸ் ஏதாவது பேசு. போர் அடிச்சா சொல்ல, ஐ வில் ஸ்டாப், தென் வி வில் ஸ்பீக் சம் அதர் டாபிக். அதுக்கப்புறம் வேணா சிலபஸ் முடிச்சுக்கலாம், நோ ப்ராப்ளம். ஓகே, இப்படி அமைதியாலாம் இருக்காது. So any doubt? Any doubt? So this is V1. If we will take V1 as common, so 1 plus 10 plus 1 plus 15. Then V2 1 by 15. This is 2, right? Equation number 1. Sorry, LCM V1 into, so it becomes 150. So 15 plus 10, 25 minus V2 into 1 by 15. So it becomes 1 by 6 minus V2 into 1 by 15. This is actually equation number 1. Okay, after simplification. Similarly, can you apply KCL at node 2? Here also it is possible to write, one-stroke equation. I am writing, but this time I think so it is not required for you people. I don't want to confuse you people. So straight away I am writing. You please apply. You just verify. KCL at node 2.
Sir, 2 by 15 or 4 by 15, sir?
Which one, ma?
V2 into 1 by 15 plus. Okay, sir.
1 by
1
5
by
தானம்மா 1 by
okay.
5. You just don't go to shortcut method, okay? The one stroke equation வேணா, you just apply as per this procedure, okay? Go step by step.
ரெண்டுமே 20 வருது சார்.
என்னம்மா?
ஆன்சர் ரெண்டுமே 20 சார்.
Yeah, very good, very good. So if you will solve, so this is my equation number 2, right? Correct, huh? That's right.
எஸ் சார்.
So now by solving equation number 1 and 2, so V1 எவ்வளோமா 20 volt and V2 also 20 volt. What is the required thing? You want to calculate I1. Therefore, what is your I1? Anyone? What is the formula for I1? I1. Here the voltage is
V1
V1.
minus V2 by 15 சார்.
So V1 minus V2 divided by 15. So 20 minus 20 divided by 15 will give you 0 amps. நான் சொன்னல என்னோட ஃபேவரட் ப்ராப்ளம் ஏன்னா ஆன்சர் 0. அதனால so it's very important. Actually, one time I did a course, okay, on circuit analysis in NPTEL. I'll then the question. So this one I took from that NPTEL course. So any doubt?
No, sir.
Okay, so we will solve one more problem. Okay, so now take example 2. So in example 2, just I want to develop the very first step. Okay, model equation alone, then manipulation and all you will do by yourself. So now take example 2.
சார் முன்னாடி நமக்கு ஒரு
சொல்லுமா.
பிரான்ச்ல ஒரே பிரான்ச்ல ரெண்டு கரண்ட் ஃப்ளோ ஆகுற மாதிரி நம்ம எடுத்திருக்கோம்ல சார்.
ஒரே பிரான்ச்ல ரெண்டு கரண்ட்லாம் ஃப்ளோ ஆகலையா? ஒரே பிரான்ச்ல
நோடல் அனாலிசிஸ் போடும்போது ரெண்டு டிஃப்ரெண்டா எடுத்திருக்கோம்ல சார். I1
எங்கம்மா?
இப்போ V1 நோட்ல இருந்து ஒரு ஒன்னு எடுத்திருப்போம்ல சார். V1 minus V2.
ஆமா.
அதே மாதிரி இந்த சைடும் எடுத்திருப்போம்ல சார். அது ரெண்டுத்தையும் ஈக்குவேட் பண்ணி ஆன்சர் கண்டுபிடிக்கலாமா சார்?
இப்ப இங்க இருந்து எடுத்திருக்க. இப்ப ஆக்சுவலி நீ இந்த நோடு 1ல எழுதுறப்ப எந்த டைரக்ஷன்ல எடுத்திருக்கிற? இந்த டைரக்ஷன்ல எடுத்திருக்க இல்லையா? அப்ப கிவனும் இந்த டைரக்ஷன்ல தான் இருக்கு. கிவன் I1, so it is in this direction only. அப்ப நோடு 1ல எழுதுனது என்னது? V1 minus V2 by 15. ஓகே. சப்போஸ் நீ நோடு 2ல எடுத்தது என்ன எடுக்கிற? ஆக்சுவலி இந்த டைரக்ஷன்ல எடுக்கிற. கரெக்டா? பட் given is in this direction. ஸோ அப்ப என்ன ஆகும்? நீ ஃபர்ஸ்ட் இந்த டைரக்ஷன்ல எடுத்த ஈக்குவேஷன் என்ன? V2 minus V1 divided by 15. ஆனா given is opposite direction. So put your minus.
Okay, sir.
Now this is my I1. Got it?
Okay, sir. Okay, sir.
Yeah, thank you. Anyway you can take, okay, but whichever way the direction coincides, okay, you want to take that. எந்த இதுல வந்து டைரக்ஷன் கோயின்சிட் ஆகுதோ அதுல பாசிட்டிவ், ஆப்போசிட் நெகட்டிவ். ஓகே, now take my final problem on nodal. Yeah, take this parallelly, don't waste your time. Yeah, this 7 amps is given it as 3 amps. Yeah, this is 1 ohm, this is 2 ohm, 3 ohm, 4 ohm, 5 ohm, question is compute V1, V2, and V3. So which one is V1, which one is V2, which one is V3? Can you take 5 minutes to solve this? Huh? Just to develop the first line, develop the nodal equation alone, the very first line of nodal equation. Then simple manipulation, it will give you everything. That is not required. Okay. So just to develop the first equation alone. In case of any doubt, and you can approach me and you can ask me, and I am waiting for your queries. In case of any doubt, please refer my board. Otherwise, you will please derive yourself. Don't copy. If I am wrong, please correct me. Have you got the same equation? Please verify with my equation. Let me know. Who is absent for today's class? Balasiddharth, PEC, Arliapa. Three more, totally 4 absentees. Okay. Vijaya,
சார் நோட் 3ல இன்னொரு டேர்ம் வரும்ல சார்?
node 3 இல்லையாப்பா? Yeah, very good.
V3
Waiting for.
-I2/3.
இல்லை நீங்களாம் கரெக்டாக எழுதலன்னு செக் பண்ணணும் இல்லையா, அதுக்காக வெயிட் பண்ணி. So yeah, very good. Intensely. So this is okay. So how many branches at node 3? Totally 4 branches. So you want to write 4 current equations, but here I have only 3. Yeah, very good. So what was the third one? Plus, what is this? V3 minus V2 divided by 3. Correct, Amma? Is it okay? Yeah, thank you. So let me put the heading super nodal. So when you will apply super nodal, you know why is it so called super nodal, right? Yeah. If the voltage source is common between two nodes, okay, then you want to apply, then we apply super nodal. Okay, so let me start with another example. This time take example number 3. To know the final answer V1, V2, V3 of example 2, please refer my material. It's given clearly. Okay, just solve the problem. You have to cross verify the final answers with my material. Now coming to example 3. Yeah, what's the very first step? You want to calculate number of essential nodes. Here how many? Actually this is one node, right? Till here node 1, and this is node 2, and this is, take my reference node. Okay, yeah. So this voltage V1 and this voltage V2. Yeah. Now between V1 and V2, you are having 9-volt source. So what you will do? First, you want to apply the very first step. Apply this time KVL at 2 per node. Okay, I am redrawing this. So it is V1 9 volt, and here it is V2. Okay, actually the equivalent is it is plus minus. This is also plus minus. Now apply KVL and let me know the equation. Yeah, apply KVL. What's the equation? The supernodal equation. Anyone?
V1 minus V2 equal to 9, sir.
So you know V1 minus V2 equals 9. Okay. Without solving like this, by seeing the branch itself, it is easy to predict. This is V1, this is V2. So V1 minus V2, and consider starting polarity. Okay, equals 9. Suppose if this kind, if it is given like this, at the time, what is my supernode equation? Anyone? So
V2
V1,
equal to 9.
sorry?
V2 minus V1 is equal to 9.
V2 minus V1 equal to 9. Yeah, otherwise V1 minus V2 equal to minus 9. Can I write like this in this way also? Okay. Or as Palani told, yeah, very good. V2 minus V1 equals 9. So both are correct, right? It's just for your information. So as of now, not required. So V1 minus V2 equals 9. This is my equation number 1. Okay. How will you develop equation number 2? Any idea? Any guess? So what you will do to develop equation number 2? Anyone? How we developed that? You want
Branch
to?
remove பண்ணிடுவோம் sir.
So you want to remove this branch. Okay. So now what you want to do? You want to apply this time KCL at node 1 and 2. Okay. At node 1, how many branches this time? Let me take this is branch number 1 and this is branch number 2 and this is branch number 3. Okay, for node 1. First we will write or we will develop for node 1. Okay, so node 1, what do you want to do? So this is entering current, so take as it is and assume these two are leaving. Okay, so entering, this time this side I want to write entering currents, this side leaving currents. Okay, just for your reference. Okay, so entering this time 3, leaving, what is the current which is flowing through branch number 3? Branch number 3, it is given by V1 minus V2 divided by 1, and branch number 2, it is V1 minus 0 divided by 5. This is for node number 1. Now coming to node 2. Node 2, this is also leaving, this is leaving, this is leaving. Okay, so time being, take this is my branch number 4 and this branch number 5. This is already I took branch number 3, so I want to take the same branch, this 3. So is there any entering current? No. So this side it is 0 actually, no entering current. Just for your reference, I am putting 0. It is not required first of all. So remaining, what is the current which is flowing through branch number 4? It is given by V2 minus 0 divided by 4. And branch number 5, clearly it is given 5 amps. And branch number 3, this time V2 minus V1 divided by 1. Okay. So now what will happen? So this is the way. So totally how many branches? So how many currents are there? You just verify that. Totally how many branches? Actually, according to node 1, 3, and according to node 1, 3 branches. According to node 2, also 3 branches. Totally 6 current. Yeah, 6 irkan bar. 1, 2, 3, 4, 5, 6. This is the way to verify. Because sometimes நமக்கே தெரியாம ஏதாவது ஒரு branch மறந்துருக்கலாம். So always the best practice, first find the number of branches at all essential nodes. Okay, in your mind itself. அதை ஜஸ்ட் நீயா கிராஸ் வெரிஃபை பண்ணிக்க. ஓகே, எத்தனை பிரான்ச் இருக்கு, அத்தனை பிரான்ச்சுக்கான கரண்ட் ஈக்குவேஷன் எழுதியிருக்குமா இல்லையா அப்படின்னு. ஓகே, திஸ் த பெஸ்ட் ப்ராக்டிஸ். அண்ட் 0 ஜஸ்ட் ஃபார் யுவர் ரெஃபரன்ஸ். இங்க வந்து 5 பிரான்ச் தான் வரும். ஏன்னா நான் நோ பிரான்ச் 3 வந்து 2 டைம் வருதுனால இந்த சேம் நேம் கொடுத்துருக்கேன். இஃப் யூ வாண்ட் டு கிவ் சம் அதர் நேம் யூ கேன் கிவ். ஓகே, as per your convenience. Nothing wrong. So now what will happen? It's V1 minus V2. This is V2 minus V1. So now what is equation number 3? 2 V1 by 5 plus V2 by 4. Equation number 2. Now solve equation number 1 and 2 and let me know the value. And this is 3, here it is 5, so 3, when 5 goes to left hand side, it becomes 3 minus 5, so minus 2. Yes, are you with me?
Yes, sir.
Is it boring? ரொம்ப சைலண்டா இருக்கீங்களா?
V2 by 4 ohm is what, sir?
V2 by 9. It is 9 ohm, right? Yeah. I thought it is 4. Yeah, 9. Very good. Thank you. ஏதாவது தப்பு பண்ணாதான் வந்து நீ வந்துட்டு மைக்கை வந்து அன்மியூட் பண்ணுவீங்களா, இல்லைன்னா மீத உட்காந்துட்டே இருக்கீங்களா? பட் யூ ஆர் லிசனிங் ரைட் ஃபார் த டைம் ஹாப்பி. பேசலன்னா கூட பரவாயில்ல, லிசன் பண்ணா ஓகே தான். So we move to the next problem. The final problem for today's class. Okay. So actually I want to start nodal analysis. Okay, with dependent sources, but என்னன்னு தெரியல, எல்லாம் ஒரு மாதிரி மந்தமா இருக்கிறீங்க. கோயம்புத்தூர்ல தான் கிளைமேட் இப்படி சில்லுன்னு இருக்குன்னா உங்க ஊர்லயுமா அப்படி இருக்கு? இல்லை இல்லையா?
இல்லைன்னா சார் இருக்கு.
ஆக்சுவலி எனக்கே கஷ்டமா தான் இருந்துச்சு காலையில குளிச்சுட்டு வர்றதுக்கு. யோசிச்சேன் நான், எனக்கு அது வாரத்துல ஒரு நாள் தான் ஃபர்ஸ்ட் ஹவர் கிளாஸ். பட் இன்னொரு செகண்ட் இயர் போறதுனால அங்கே ஒரு கிளாஸ் இருக்கும். ஸோ வீக்லி 2 days தான் ஃபர்ஸ்ட் ஹவர் கிளாஸ். ஆனால் வாரத்தில் 5 நாளும் ஃபர்ஸ்ட் ஹவர் கிளாஸ் கஷ்டம் தான். தட் ஐ அக்செப்ட் தட். அதுக்காக பேசாமல் இருக்காது. ஸோ கேன் ஐ மூவ் டு த நெக்ஸ்ட் ப்ராப்ளம்? ஸோ திஸ் டைம் ஐ வாண்ட் டு பிளே வித் 3 loops. Okay, so take the problem. It is also quite interesting problem. It is taken from our director 8th. Okay, I hope so you will enjoy this problem. Now take this. It's quite challenging one. Compute all nodal voltages. Vignesh, what's the very first step in nodal analysis?
Sir, essential notes conduct.
Okay, இங்க எத்தனை essential nodes?
Sir, 3 இருக்கு sir.
Here 4.
Fourth reference இல்லையா sir?
Totally, always here. Okay, so take totally 4, but you want to take the fourth one. Always take the bottom one as reference. Okay. So can you find V1, V2, and V3 by yourself? What's the very first step? Here between V2 and V3, okay, between V2 and V3, you are having one voltage source. So it is coming under supernodal. So what is the equation for supernodal? What's the very first step? You will apply this time KVL at supernode. Apply KVL at supernode. What is the equation? What's the equation, ma? Thank you.
Sir, V2 minus V3 equal to 4.
Yeah, thank you. So straight away I am writing. Okay, you guys, you please do all the tinkering work and all by yourself. Just redraw and apply KVL and all. So V2 minus V3 by 4, equation number 1. Okay. So after that, what you will do? This time you will apply KCL at node 2 and 3. Okay. So before that, what you will do? You will remove branch number 4, branch number, this branch. Okay. So here it's very important. So this time totally how many current, okay, will come in equation number 2. Branch 2 ல எத்தனை இருக்குன்னு பாரு, எத்தனை, sorry, node 2 ல எத்தனை branch இருக்கு? 1, 2, 3. Can I write this is 1, this is 2, and this is 3. Coming to node 3, can I take this is branch number 4, this is 5, and this is 6. So 6 components, 6 equations, okay, 6 current terms, okay, in will come in equation number 2. So what are those? First, என்ன பண்ணலாம்? You want to assume the current direction. Actually, this is entering. So remaining 2 is leaving. So what is the entering current? This side entering current and this side leaving current. Okay, I want to write like this. So entering current 5 and leaving. What is the current which is flowing through branch 1? It is V2 minus V1 by, what is this value? This is 5 ohm. Okay, so V2 minus V1 by 5. What is the current which is flowing through branch 3? It is V2 minus 0 by 3. It's very simple actually nodal analysis, but ரொம்ப கான்சென்ட்ரேஷனோட இருக்கணும். ஓகே, கான்சென்ட்ரேட் பண்ணி பண்ணணும். Then only, so you want to be careful. So 3 over, coming to branch, coming to node 3. So this time I want to take, this is branch number. So 4, 5, 6 already I have taken. So, and I want to assume the current direction. Assume all are leaving. So there is no entering, not a problem. So plus 8 plus, right away I am writing V3 minus 0 by 2 plus V3 minus V1 by 1. Okay. You simple manipulate, then you will get a final equation. So totally 6 terms are there. Yeah, just to verify. 1, 2, 3, 4, 5, 6. Yeah, 6 is there. Not a problem. After that, what you will do? You will apply KCL at apply KCL at node 1. Coming to node 1, how many branches? So 1, 2, 3, 4, 5, 6. I want to start from 7, 8, 9, 10. So take this is 7, this is 8, this is 9, and this is 10. Okay, and assume the current direction. This is entering, and I want to assume remaining all are leaving. So this time apply KVL. So entering current 3 equals sum of 3 leaving currents. Current which is flowing through 5 ohm resistor is V1 minus V2 by 5 plus 5 ohms plus V1 minus V3 divided by 1. Current which is flowing through branch number 10 is number 3. Any doubt?
சார் இப்போ கேசிஎல் நோட் 2 and 3க்கு பதிலாக 1 and 2 பண்ணி அப்புறம் 3 தனியா பண்ணலாமா சார்?
1 and 2 எப்படி பண்ணுவேன்? 3 எப்படி சரியா பண்ண முடியும்? ஏன்னா எனக்கு காமன் வோல்டேஜ் சோர்ஸ் எங்க இருக்கு? பிட்வீன் 2 and 3 தானே இருக்கு.
ஓகே சார்.
அப்புறம் நம்ம என்ன பண்ணணும்? ஃபர்ஸ்ட் அப்ளை கேவிஎல் அட் சூப்பர் நோட். அதுக்கப்புறம் அந்த பிரான்ச்சை ரிமூவ் பண்ணனா அந்த பிரான்ச் எங்க இருந்து ரிமூவ் பண்ற? 2ல இருந்து 3ல இருந்து ரிமூவ் பண்ற. அப்ப யூ வாண்ட் டு ரைட் ஓகே ஒன் காமன் ஈக்குவேஷன் ஃபார் நோடு 2 and 3. இங்க வந்து எப்படி 3 வந்து செப்பரேட்டா வரும்? 3 செப்பரேட்டா வரணும்னா அப்ப யூ வாண்ட் டு ஹேவ் ஏ காமன் சோர்ஸ், காமன் வோல்டேஜ் சோர்ஸ் பிட்வீன் நோடு 1 and 2. புரியுதா? நோடு 1 and 2க்கு இடையில ஒரு வோல்டேஜ் சோர்ஸ் இருந்துச்சுன்னா அப்பதான் 3 செப்பரேட்டா வரும். இங்க எப்படி இருக்கு? நோடு 2 and 3ல between node 2 and 3 you are having one voltage source. So this time you are writing separate equation for node 1. Akshay Kumara.
ஓகே சார், புரிஞ்சுது.
புரிஞ்சா? Thank you. Have you taken? So I think we can wind up. Okay, but before that I want to give you only one homework problem for you people. So next put the heading. What's the next heading? So nodal analysis with dependent sources. Please let me put the heading. Nodal analysis with dependent source. So take only one problem. Actually, this is for tomorrow's class. So let me put example number 1. Okay, if you are having enough time, please solve it. No, diamond symbol, you know. So actually, we are going to play with dependent source. Question is compute all model voltages. Okay. So that's it for today's class. So any doubt? Have you taken this? முடிச்சுக்கலாமா?
Yes, sir.
Okay.
Okay. Any more doubts? So those who are having doubts, you can stay. Otherwise, you can go to your next class. Okay. So thank you. Thanks for your attention. So once again, thank you.